Unlike a lot of mixture problems in algebra books, here's one that really does look pretty realistic. Let me read it to you, make sure you can read my handwriting. A company has a stock of 22% copper alloy. That means this material, 22% of it is copper, and the other 78% is something else. And it also has 36% copper alloy. How many pounds of each must be mixed in order to produce 120 pounds of a 26% copper alloy? So you can well imagine that the company that works with metals might have to do something like this. Someone may have to work a calculation. So this really is pretty realistic, I believe. Okay, well, how many pounds of each? How are we going to define that? Well, we have a 22% alloy and we have a 36% copper alloy. We could call it X and Y. How about W and S for weak and strong? So W is the pounds of the 22% alloy, and S is pounds of the 36% alloy. So I use W and S for weak and strong. There's less chance I'll get my variables mixed up if I describe them with a letter. And I like to, when I use S, I like to do a lowercase cursive s, since my capital S's tend to look like my 5s. So if you make letters which look like numbers, you might want to keep that in mind. Because I have seen people get those mixed up. All right. So what does it mean to have these percent alloys? And when we get done, we're going to have 120 pounds of a 26% alloy. That means 26% of that is the number of pounds just in pure copper. And the other thing is, and so it goes the same way here. 22% of these pounds will be pure copper, and 36% of these number of pounds will be pure copper. So you might wonder, well, okay, I have two unknowns. What are the two clues to the problem? And one of them clearly is that we have to produce a 26% copper alloy, 120 pounds. The other clue is a little bit hidden, and it's the 120 pounds. We need these to add up to 120 pounds. So I've seen people get stumped on these problems because they're not writing down properly what their letters represent. Usually my students write down something because they think, you know, I talked about it, maybe they should. But if you wrote W equals 22%, what does that tell you? It tells me nothing, because I want to solve for a letter. This one looks like it's already solved. And so be descriptive. Pounds of the 22% alloy. All right, so let's see here. We're going to mix these quantities together. So imagine that I have one pile of this weak alloy. I'm going to melt it down and add to this other pile of alloy, which is melted down. This gets mixed together. So I'm adding these quantities together to get this new quantity, the 26% alloy. But I need 120 pounds. So since these describe pounds, W pounds plus S pounds equals to 120 pounds. So I didn't write the units in there, but this is, let me write those units in. We'll have time to work the algebra later. So W pounds plus S pounds equals 120 pounds. All right. So if you spot that clue, then that's actually the easy clue, 120 pounds. Now to get the 26% copper alloy, I need to, that 26% of 120 is the amount of pure copper. So actually what we're working with with the other clue is the amount of pure copper. So let's consider the 22% stuff. And so if I take 22% of W pounds and I add that to 36% of the S pounds, then I should get 26% of 120 pounds. So look at my units there. Percent of means to multiply. And really it's, and technically it's 22 pounds of copper per 100 pounds total metal. 22 pounds copper over 100 pounds metal, and we multiply by W pounds of metal, then the metal cancels, leaving pounds of copper. So essentially that's what we were doing here. The units will work. It's a little complicated with these units, and my handwriting was exceptionally bad there. But taking 22% of it, if 22% is copper, then 22% of W is the pounds of copper. So this describes the amount of pure copper, this describes the amount of pure copper, and that describes the amount of pure copper. So you see that if I left off the of 120 pounds here, if this was missing, then I would have a mismatch of units. I would have pounds of copper plus pounds of copper equals 26%. 26% of what? And so I've seen people do that a lot. All right, I'm going to recopy these in a more algebraic form so we can finish solving. So the units all work out. So we have, what did we have? We had W plus S equals to 120. We had 0.22 W plus 0.36 S equals to 0.26 times 120. And we can simplify the right side there. So let's see, 0.26 times 120 is 31.2. So the right side is 31.2, and again, this would be pounds of pure copper.